Hey guys, I'm just going to introduce your next assignment and what you'll be working on for the start of this term. Now that we're not in the actual workshop, and the aim is to get all the theory done now, so that hopefully when we return, that we can just get straight into prac. So to do this, let's start off by going to our Teams page, into the classroom notebook. You've got term 1 and here's term 2. You'll notice a new tab here, which is where should I be at? Okay, now if we click on that, that's going to be what you can go to and look at for your own self to go, oh, this is where I need to be in week 1. What should I have done? I should have finished investigation and research questions, ready to start concept sketches. And you can show your parents this as well and go, well, this is what's due and this is what I've done. So that's something to look at. And it says here each week you will be set a task, and by 3 p.m. Friday you'll need to load the completed work onto that week's draft assignment task. Okay, so in assignments I'm going to set the task, so you're going to need to load up week 1 into the assignment tab, just so that I can check on it every week, and I'll be expecting that 3 p.m. Friday. Rightio, so let's have a look at this assignment to start off with. So if we go to Learning Cycle 3, Metal Craft Design, you'll see the task sheet here. There's some other resources here as well, but for today's lesson we're going to focus on this task sheet. So you can download that, and this is what it looks like. Planes, trains and automobiles, so that's what we're calling this design challenge. And if we have a look at the design problem, Arul Pico, head of sales from Gardening Art Australia, is searching for new designs to help for his year's range of art. For this year's range of garden art, he needs your help and has given the following design brief. So that's the problem. We're now going to look at the brief, and this is what Pico has given us. Now, he says, design and construct a metal craft ornament using the sheet metal and fitting and machining skills you have learnt this semester. So if we think back to what we've learnt, making the parts tray, making the fishing reel spooler, we want to combine what we've learnt there plus some other skills that we're going to learn as well to create this ornament. And so it says here, to be made predominantly from mild steel flat bar and other recycled items in the workshop. The finished product should be suitable for decorating a garden, patio, or a desktop of your chosen target audience. Now, I'm just going to sit on this one for a little bit. For your chosen target audience. So I'm not saying that you have to design this for a 12-year-old, for a 50-year-old, whatever. You get to choose your target audience. Okay, your design must meet the following design criteria. So it's to be no larger than an A3 piece of paper. Now, I'll show you how we're going to measure that exactly, because we're not making something that is 2D. It's going to be 3D, you know, but we're going to use that piece of paper for our size limit, and I'll try and make that clear on this video. The finished product will be free from sharp edges, so it's going to be nice and safe. It would be desirable for it to have a second function. Okay. So it could be a desk tidy, doorway, pot plant opener, pot plant holder, bottle opener, whatever you can think of. If it can have a second use, that would be even better. Must use a machine component. So part or parts made on the lathe. So I'll show you a couple of examples of how you could do that. But you need to incorporate a little bit of lathe work in the design. Needs to appeal to the target audience. Use recycled metal where possible. So you can use the scrap steel from around the workshop. You could use old machine parts from the local bike shop, whatever you wanted, and put them all together. So let's take a look at some examples, and then we'll have a look into target audience and stuff like that. So here's some previous students' work. Here's a submarine, an aeroplane, motorbike, a skateboard. You can really go wherever you want with this as long as you're using the techniques and the material that we've prescribed. So you need to decide who your target audience is going to be. Now, if you want it to be yourself, well, you would say that it is a Year 10 student at Unity College. It then asks you to list 3 areas of interest that would appeal to them. So if your target audience was your father, you might list 3 areas that would appeal to him. So fishing might be one of them, motorsport, pressing wildflowers, who knows. So you can list those areas there, and you might say, who's your target audience? And you might go, okay, I want to do it for my dad. You might then want to go interview your dad and say, what's something that would really appeal to you if I made you a garden ornament, or if I made you something for your shed or whatever. Because the next question says, now that you know more about your target audience, list 1 more design criteria. So design criteria is something that it must do, that must be met by your final design. So go back up here. Here's our design criteria. This is the list of things it must do. So you might, be designing it for your uncle and find out that he is madly in love with John Deere tractors. And so in your final design, you might say that it must incorporate something to do with John Deere so that it has a John Deere flavour or an element within that final design. And so you can write that there. And then what's going to happen is when you've finished your design and, it looks something like this, you're going to go through your design criteria and you're going to say, well, is it no larger than A3? Check. Is it free from sharp edges? Check. Did it have a John Deere flavour to it? Check. Okay. So normally what we would do is I'd talk like I've just talked now about the assignment. I'd probably buzz around the room and see who's got a target audience, what they might design, if they've got any ideas floating in their head. But one of the biggest things we need to do is experiment with the material and figure out how the material works and what it can and can't do, because that's going to ultimately limit my design in a sense. And so there's a couple of questions here. Now, the first one is, list some ways you can join mild steel flat bar together. So let's take a look at some photos first and we'll come back. I'll read these other ones so that they're fresh in my head and might be able to talk about them at the same time. Can steel be welded to aluminium? We'll answer that in a second. If so, how? If not, how can you join them? And then it asks a question here, welding versus fixing with rivets or bolts. Explain why someone would choose one over the other and give an example. So that's part of your work that you need to do this week. So if you look at this, you've got to fill in all that this week. And then you need to do a PMI on existing products as well. But let's take a look at these materials that we would normally, right now, we would go and have a little look in the workshop. So I'm just going to go back to the start of my photos here. Okay, so there's the example that we one of the teachers has made. And so we're using some leftover scrap around the workshop. This here is what we're calling the flat bar. I think it's 25 by 3mm flat bar that we can bend up. We have machines that can create perfect circles in the workshop. We also have lots of pipe laying around that we could cut and use that pipe there as one of the wheels. There's a better photo that shows it there. One of the questions was, how can flat bar be joined? If we take a look here, and I think I've got some close-up photos towards the back here. You guys haven't done this yet, but it's called welding, and we're going to be able to tack weld our ornament together. Now, we're able to do that with the nice thick bar. We can weld 3mm to 3mm. What we can't really do is weld sheet metal. So what you made your parts tray, can't weld that to the thicker plate would have to pop rivet that on, drill a hole and put a pop rivet in, which is what we've done before. This is a photo of one of our scrollers. Okay, so this is what we can use to create arcs. Now I've created that nice flowing arc there, and that might be part of your design within the frame of a motorbike or whatever you decide to do. And here's, I've taken these photos here because I was trying to think, normally I would be showing you this in the workshop, but this is just a little rundown of how the process is going to evolve. So I'm going to try and find a better photo for you. So this would be considered almost a good copy. This would be one of my ideation sketches. It's not due this week. We'll do that next week. But I just need to show you this now so you can start planning and get a bit of an idea. So I'm going to create a side view of that motorbike, and there's my A3 piece of paper, so hence the size limit. I'm then going to start creating my parts. So I've already got a wheel ready to go. And then if I scroll through, I'm just going to start creating my frame. So I've got a bit of flat bar, and I'm going to keep bending it in the machines until I can get it to follow. Here's another part of our bender there, to follow the profile of the sketch that I put on the piece of paper. So I think that's about as far as I've gone with my photos as to how the process of making the frame is going to happen in the workshop. But what you needed to get from this, and I would have normally given you a piece of scrap steel and said, hey, see what bends you can complete on it, is that this is about the limit of the type of bends that I can create on our machine. You'll see that there's no bends. I haven't done any hairpin bends where it bends all the way back on itself or anything like that. This little section that I've drawn in here is for the seat. I'm actually going to cut a separate piece and just do a nice little bend there. It's probably 60 degrees, and I'll put a tack there and there. So the aim of today's lesson, if you were in the workshop, would have been to play with this machine and figure out what it can and can't do. So what it can't do any crazy hairpin bends or anything like that, because it simply just gets stuck inside of the machine. What it can do is nice free-flowing arcs, and sometimes it's a bit easier just to cut it there, do a join and bend it back over, bend another piece back over it and weld it together like that. So that's something to play around with, and it's going to be interesting to see some of the designs that you come up with, given that we're doing this remotely at the moment. So I can't wait to see what some of you guys are going to come up with in isolation. So I think that answers that. Welding, if we go back to looking at some of the welds here, I can only weld steel to steel. Okay. If I wanted to join aluminium, now that's a piece of steel, it's just shiny because it hasn't rusted yet. If I wanted to join aluminium to the motorbike, I would have to use either a chemical adhesive, so an epoxy glue, or I'd have to drill and rivet or drill and bolt the aluminium to the steel. Now, I'm not going to go too far into it, but mixing metals isn't always a good idea due to rust and other things like that. But it can be done, but it would have to be a mechanical fastening to join the aluminium to the steel. Now, there's some other questions there within your sheet, and I'm going to let you do your own research there, and I'd be interested to see what answers you come up with. You can also discuss it within the chat. But I've got these photos here to show you, because there's an element there where it says you need to have a turned item. Now I've created this on the lathe out of a piece of round steel, and this is exactly what you've done last term. I faced it off, put a little indent in there, and then I parted the piece off, and there it is there. And I'm going to use that as my headlight, and I'll weld that to the front of the bike. And because it's steel, it will just tack straight on. I could have used it as my air intake on the side of the motor. I reckon that's a nice little addition. Looks kind of cool. So once again, I can tack that on. And I think that's about it for now, guys, with this. Here was just some of the different material we had. So we've got some hex brass and some round. I think this brass here would look pretty cool if we machine that and attach it to the bike. Once again, it would be brass. So brass is a different material to steel. So joining it, you would have to drill a hole in it and either rivet or bolt it, or glue it. I'm leaning towards riveting and bolting because the glue is not going to last as long as that. Here's a good view of which will answer some of your research questions. Now, these were plasma cut, and I'm more than happy to cut a heap of these little pieces so you can make your own engine, because I've got the file sitting there for your vehicle or whatever you decide to do. But you'll see it's a sandwich of mild steel, aluminium, just to give it a bit of colour contrast. Two different metals, can't be welded together, but I can bolt them together. Okay, and then I get the contrasting colour. So I think that pretty much answers the questions. I'm just going to come back to the Word document here. Anything that I've missed, or if you've got any other questions, just put it into the chat and I'll try and update it. But ultimately, I just want to make one video that's got all of this week's content in it. Hopefully you haven't fallen asleep yet and you're still listening. So that answers that there. You'll be able to add to that using some of your own research there. Find some existing products, do a plus, minus and interesting on them. We've done that before in class, so that should be nothing new to you there. And then that's all you need to do. We're going to do the design concept sketches next week. But for now, I just want you to think about these questions, who your target audience is, and all of that there. Okay, I think that pretty much covers it. And I've talked for way too long.